Hello, my dear student. You are most welcome to my class. Myself, Dr Apil. My dear student, today also I will discuss some important questions and some important theorems and some basic concept on complex analysis. So hope this lecture also will be helpful for all of you. Okay, guys, you see here in the last class we have discussed some basic concept on complex number and some standard form. You see, any complex number we can write like this. Okay, about this thing already we have discussed in the last class. Just I will try to recall this thing, basic properties here. Here you see this x and y, these are the real numbers and this I is imaginary number, right? And this x is called here the real part of this complex number and this y is called the imaginary part of this complex number. And sometimes this complex number we can write like this way also. Okay, x comma y, where this x is the real part, y is the imaginary part. So this way also we can denote. Okay, this thing already we have discussed in the last class. So today we will discuss some important concept here, some important properties also we will discuss. Okay, so you see one concept is that here equality of two complex number or equality of complex number, right? That means when two or more complex number are called equal, right? So here you see, if we consider two complex numbers, suppose we consider this is one complex number and this is another complex number, right? This is another complex number. These two complex numbers are said to be equal only when their corresponding components or real part and the corresponding imaginary parts are equal. That means if we consider, suppose x1 y1, this is a complex number, another is x2 and y2, these two are the complex number, then these two will be equal only when this part, that means this x1 and x2 are equal and here y1 and y2 are equal. If this is happened, then we call these two complex number are equal. Is it okay? So that means what we see, if their corresponding real parts and imaginary parts are equal, then we can say that complex number are equal. And conversely also we can say, if these two complex number are equal, then their real parts and the corresponding imaginary parts will be here. If you see, some fundamental laws are there which we need. Okay, I think these are very easy. You see here, first thing here, addition, how we can add two complex number. Here you see, suppose we consider these two are the complex number, then what will be the sum of these two complex number? You see how we can find the sum? Just you need to take the sum of this real part and the corresponding imaginary part only. That means sum of these two complex number will be here x1 plus x2, right? And here y1 plus y2. So this will be the sum of these two complex number. Here you see, suppose if we consider 2, 3, this is a complex number, 5. Okay, then what will be their sum? Sum will be like this way, 2 plus 1, that means this real comma this imaginary, that means 3 plus 5. So what will be this value? This will be 3, 8. Okay, so this will be the required sum of these two complex numbers. Don't forget, these complex numbers we can write like this way also. Okay, 2 plus 3i. Okay, this one we can write like this way, plus how we can write like this way, this is 1 plus of 5i. This way also we can write, right? So similarly 2 plus 1, that means this will be 3, and 3 plus 5, what will be this one? This will be 8. So 3 plus 8, right? So this way we can write also, or this format also we can use. So 3, 4, 5, any number of complex number we can easily find. So I think the sum of any number of complex number we can easily find. And similarly, in case of difference also we can find same way. If we write here difference, suppose we need the value difference, then here we need to put just here difference. Okay, here we need to put what? Difference. Is it okay? That means what will be the difference of these two one? This will be here 2 minus 1 and 3 minus of 5, right? So what will be this value? This will be 1 comma minus of 2. So this will be the difference of these two complex number. So I think all of you can easily find this sum and difference of any two complex number or any more number of complex number, right? But here you see, in case of sum and difference, it's easy, very easy to find, right? Because we need to deal with the corresponding real and imaginary parts only. But in case of multiplication, right? Suppose we consider these two are the complex number and we want to find the multiplication. Now you see, in case of addition, just we operate just corresponding elements of first component and the second component, right? But here, is it same as like this one? No. Here you see, this is real, this is real, so we can find like this way, x1 comma x2, right? And y1 comma y2. This way we can find, right? We can find like this way. This will be little bit different, right? So you see, just I will try to find the product of this complex number. Here you see, this x1 means this one means here x1 comma y1 means this is the complex number, and x2 plus I of y2, this is the second complex number. Just you try to multiply this, and then what we get here, this will be x1 comma x2, x1 into x2 plus x1 y2 and I plus here what will be this value, y1 x2 of I, and here I plus I into I, matlab I square y1 y2 will get, right? So you try to multiply, okay? Then what we get here, you will get here x1 x2, right? x1 x2 plus here, from here you can take I common, so here will be x1 y2 plus y1 x2, right? And here this I square is minus 1, that means this will be y1 y2. So finally what we get here, you see, x1 x2 minus y1 y2 plus I of x1 y2 plus y1 x2 plus. So this is the product of these two complex number, right? And this thing we can write like this way also, right? x1 x2 minus y1 y2 comma x1 y2 plus y1 x2. So this is the product of these two complex number, right? So this is this thing I write here. So the commutative law of addition, right? Commutative law of addition, that means here this one, if we consider z1 is a complex number, z2 is a complex number, then z1 plus z2 is equal to z2 plus z1, right? If this is happened, then we call the commutative property is satisfied. So in case of addition, the complex number is satisfied, always satisfy this property. So that's why we can say the set of complex number or complex number always satisfy the commutative property with respect to addition, right? So here you see, suppose if we consider z1 means here 2 plus 3i, okay? Suppose z2 is nothing, 3 plus 5i. So what will be z1 plus z2? Just you try to verify. What will be z1 plus z2? This will be 2 plus 3 means 5 plus 5 plus 3, that means 8, right? This will be z1 plus z2, right? Similarly, z2 plus z1, what will be this value? Here you see 3 plus 2, again we will get 5, here 5 plus 3, 8i, that means here you see these two values always will be equal. So that means this z1 plus z2, z2 plus z1 always will be equal here in case of addition, right? And another more important concept is that, or property is that, which is called the associative property. So this is the associative property. Here you see, this is called the associative property. Here you see, first of all we just take sum of these two on first, after that we take sum with this one. But here on the right side, here you see just we take sum of the first one and then the last one, right? So if these two values are equal, then we call the associative property is satisfied, right? And of course we can easily verify that the set of complex number always will satisfy this associative property. Is it okay? You can easily verify by using this type of some numerical values object, right? We can easily verify. And similarly, in case of multiplication, here you see, in case of multiplication, here you see this commutative law always will be satisfied. Here you see Z1 into Z2 will be Z2 into Z1. This is always happen, we can easily verify. And in case of multiplication, this associative law also will satisfy, right? We can easily verify this thing. But what about the subtraction? This is important, right? Subtraction. In case of subtraction, whether this commutative property is satisfied, that means whether Z1 minus of Z2 and Z2 minus of Z1 are they equal? Okay, let's verify. Suppose we consider this Z1 is nothing 2 plus I, right? And Z2 is here 3 plus of 5I. We consider this one. Then what will be Z1 minus Z2? You just check what will be Z1 minus Z2. This will be 2 minus 3. 2 minus 3 means here minus of 1, right? Minus 1. And I minus of 5I. That means what we get? Minus of 4I will get. So this is Z1 minus of Z2. But what will be Z2 minus Z1? That means 3 minus of 2. This is 1. 5I minus of I will be here 4I. Now you check whether they are equal. No. That means in case of subtraction, the set of integer is not satisfied the commutative property, right? So similarly, we can easily verify that in case of associative property with respect to this subtraction is not hold here, right? That means the associative property is not hold or is not satisfied with respect to subtraction also, right? So you can easily verify values here. Suppose Z3 is suppose 1 plus of twice. Okay, we consider these three complex number here. In case of associativity, what will be Z1 minus of Z2 minus of Z3? Okay, this is Z1. Z1 means here this one, to 2 plus I. Okay, minus what will be Z2 minus Z3? Z2 minus means 3 minus 1, 2. 5I minus of 2I, that means 3 of I will be there. So what will be this value? 2 minus 2 means 0. I minus 3I matlab twice of I. So this will be the value of this one, right? And similarly, you just try to find this value. Z1 minus of Z2 of minus of Z3. Okay, first you find Z1 minus Z2. That means 2 minus of 3. What is this? This will be minus 1. I minus of 5I. That means minus of 4I will get here. Okay, minus what is Z3? Our Z3 is our what? Z3 is our 1 minus of twice I. So you put here 1 minus of twice I. Okay, so 1 plus twice I, not the minus, right? Here 1 plus twice. So just you try to simplify. Minus 1. So this will be minus of 2, right? Minus 4I minus of twice I will be there. That means minus of 6I will be there. 6I, right? So now you check whether they are equal. No. That means in case of subtraction, this associative property is not hold, right? So one more properties is there which is called the distributive property, right? Distributive property, and this is called the distributive property. This is similar as this property. I think this thing already you know, right? A into B plus A into C, right? This is similar as this one, and this is called the distributive property, and this property always hold in case of complex number, right? और एक कॉन्सेप्ट देखो विच इज कॉल्ड एडिटिव आइडेंटिटी। देखो एडिटिव आइडेंटिटी क्या होता है, ऐसा एक नंबर होता है और इस डेफिनेटली ऐसा एक कॉम्प्लेक्स नंबर होता है जिसका साथ हम लोग कोई भी कॉम्प्लेक्स नंबर को ऐड करने से ना वही कॉम्प्लेक्स नंबर हमेशा देता है, ठीक है। तो यहाँ में देखो जैसे कॉम्प्लेक्स नंबर 0, so this 0 means here 0 plus I into 0, that means 0, 0, right? Here you see this is the complex number, right? And if we take any complex number, suppose x, y, and if we take sum of this x, y with this 0, 0, then what we get? देखो this will be x plus 0 and y plus 0. So this thing will get here by using use the property sum property, right? So what will be this below? This will be x plus 0, y plus 0, that means x, y. So you see here 0, 0 is a complex number, or simply 0 plus I0 is a complex number, ठीक है। इसके साथ कोई भी कॉम्प्लेक्स नंबर तुम ऐड करो वही कॉम्प्लेक्स नंबर होता है। दैट मीन्स दिस 0, 0 इज नथिंग, दिस इज आवर एडिटिव आइडेंटिटी और आइडेंटिटी with respect to addition, right? So with respect to addition, so this 0, 0 or this 0 complex number is called here the additive identity, okay? So you just remember this thing. And similarly additive inverse is there. Now what will be the additive inverse? So here you see, if we consider any complex number, suppose x, y, then you just search another complex number such that their sum is equal to the additive identity, and that number will be here minus x and minus 1. You see here why this is minus x minus y, because you see if we take the sum of these two complex number, this will be x minus y, and here x minus x, and here will be y minus y, and this is nothing 0, 0, because this is 0, this is 0. So what we get here for this x, y, this minus x and minus y is here, such that their sum always will be here 0, 0, right? So in this case this minus x and minus y is called the additive inverse of this complex number, right? And also we can say here this x, y is the additive inverse of this one, right? Why you call this is the additive inverse of this one, or this is the additive inverse of this one? Because you see their sum is always will get here identity element, right? So here you see suppose 2 plus 3i, so what will be the additive inverse of this one? So of course the additive inverse will be minus 2 minus 3i, right? So this is the additive inverse of this one. Or suppose 2 minus of 3i is there, what will be the additive inverse of this one? The additive inverse of this one will be minus 2 plus 3i, so this will be the additive inverse of this one. You see, just we need to change the sign of the real part and imaginary part only, right? Here you see 2 plus 3i, so here plus plus, so we put here minus. Here you see plus and minus, so we put here minus and plus. That means just we need to change the sign of the real as well as the complex, imaginary part only, right? So I hope all of you can easily find the additive inverse of any complex number. Similarly, multiplicative identity. Here you see there is a complex number, this one. Suppose z equal to 1, or we can write like this, 0 into I, or 1, 0. This is the complex number. You see, for this complex number, if we consider any complex number, x, 1, and if we multiply this two complex number, now you use the product rule, right? What was the product rule? You see, you must remember that one, x1, y1, x2, y2. What is that? x1, x2 minus y1, y2. This is the first component, and here x on y2 plus y on x2. Bas, this is the product, right? So just use this formula here, you can easily find the product. So x on x2, that means x into 1 plus minus y on y2. Y on is y, y2 is 0, so y on y2, right? Okay, comma, then x on y2. X1 means x, y1 is y2 is 0, so x1, so this one will get here, so this value will be here, you see, x minus of 0, that means x, and here also you get a 0 plus y, that means x comma y. So that means this complex number or this complex number there exists, and if we multiple any complex number with this complex number, we always get that complex number, right? So in this case we call here this complex number is called the multiplicative identity, right? So you must remember this one is the multiplicative identity, or this is the multiplicative identity of complex number.